I'm Jason Robinson. I'm from Toronto, Ontario, Canada. I arrived here on Tuesday, so this is my second day of jet lag, so bear with me if I'm trying to figure out what I'm talking about up here. But basically what I am talking about is net zero with plant-based materials. And Evoco is a technology innovation company focused on replacing petrochemistry with plant-based chemistry. Oil, which is a raw material for petrochemistry, is basically in everything we walk on, wear, sit on, sleep on, and drive in. And by using plants, not only is the opportunity for plants to be scalable, but they actually are more impactful, and we'll prove this with some data, on reducing your carbon emissions than a lot of other alternatives. Fashion and footwear account for 10% of global emissions. Actually, other published data is much higher than that, of which 40% of those emissions, or 4 to 5% of global emissions, are attributed to the materials found in fashion and footwear. A typical pair of running shoes, weigh about 400 grams, and but release through its life cycle about 15 kilograms of CO2. So you can imagine something that is used to run in and very light actually emits 15 kilograms of CO2. That's quite significant. On top of that, there is a huge waste issue in the industry. Everything is, especially around the fast fashion mentality, you wear it, you throw it away, it's discarded, it ends up in landfills, and it doesn't degrade. It just sits there and piles up and piles up. 1 million cubic meters of PU materials are made, equivalent to the volume of the Empire State Building, and discarded and not recycled. In fact, very little of these materials can be recycled or are circular. So aside from the problem, Evoco is focused on these 4 pillars, which is the idea of renewability, so utilizing plants to reduce your carbon footprint, the idea that we can create chemistry and materials to actually create performance-based products. With sustainable production, actually, we do a lot of work on taking a lot of these toxic compounds and materials out of the products you use every day, things like certain types of catalysts, heavy metals, solvents. Specifically, there's a lot of discussion around tin and tin-based catalysts used in a variety of different industries to make the reactions work. It's actually a very hazardous material and persistent in the environment, meaning it leaches out of these materials and sits in the environment forever. So these things are not found in our materials, and we can still make these materials perform and work in a productive way in manufacturing. On top of that, we are very much focused on waste diversion. Less so on recycling, even though we do use pre-consumer and waste reduction protocols around production, but we are focused on this idea of degradation, biodegradation naturally in the environment. This should be really a circle, but we think more about natural circularity, not product circularity, but natural circularity, and that's the circulation of carbon. And you can do that when you start as a raw material with plants. Plants are made from the carbon today, not carbon of 250 million years ago, but turned from fossils into oil, and it can make a variety of different chemistries, or polymers, or materials and products. We have created a product called the Fates Eco Foam, which not only performs and has enduring performance characteristics, meaning it lasts longer while in use, but it actually biodegrades at its end of life. And I don't want to get into supply chain issues with biodegradation. What I want to talk about is the impact at the end of life when it does get thrown away, which it will, just like everything else. It will degrade in both aerobic, anaerobic systems, compostability, and anaerobic, which is landfill, okay? But the idea of natural circularity is this idea that the carbon that goes into the plants will actually go back into the earth. So carbon is actually trapped in a cycle, which is what carbon used to naturally do before we started drilling it out of the ground. Our innovation platform basically is vertically integrated. We start from the biomass and work on a variety of different types of biomass or plant-based materials. So we call it feedstock agnostic. And we focus on not only deriving new monomers, new chemistry, but also turning those into polymers or biocomposites or other materials that we can then turn into a product. So we're a vertically integrated company focusing on the innovation side and focusing on production. So we have our own production facility in Vietnam. We're actually making products today for customers that are actually using it in their shoes. This is the Fates EcoFoam. Oh, I stole my next slide's thunder. This is the Fates EcoFoam. It's a third-party certified 70 to 80% plant-based material that's highly functional, high-performance product, low compression set, high rebound, but the really concept behind this is it's highly carbon reducing, and it's third-party certified with USDA certified bio-based product, Green Circle certified, which actually go through our whole supply chain to make sure the mass balance adds up, that we're actually giving you 70 to 80% as a product, and also vegan verified. The key aspect around this is that we're really trying to push the boundaries on a product that is available today, while innovating to not only increase the bio content, but on certain performance metrics as we expand the opportunities for foams into other things like thermoplastics, coatings, and adhesives into products such as yoga mats and furniture and other applications. So one of the things I think we've heard a lot about in the communication is this idea of greenwashing and transparency and what we need to do to understand the impact of these technologies. We publish our life cycle analysis. Well, now you see it, right? So it's in the public domain. This is a third-party verified life cycle analysis. We have our own in-house team that use SimaPro as we utilize existing databases and build up our own database of materials, carbon footprints along an entire life cycle analysis. And this is based on an ISO standard, okay? So when you look at, when people start talking about life cycle analysis, and they start telling you that, well, there's different ways to work on a life cycle analysis. There actually isn't. It's a carbon balance along the entire value chain from cradle to cradle or cradle to grave, okay? And so when we look at our technology, it is, from an industrial perspective, it is a much lower than not only polyurethanes, but other products used in kind of footwear technologies like EVAs and PVCs and other types of materials. But the face of today is the 72, 75% material, and as we work on new technologies, we have technologies that range between 1 and 2 kilograms of CO2 equivalent, which is significantly less than industrial standards, polyurethanes, and other types of materials. Part of our messaging too is really, this idea of plant-based and how we can move to net zero with this concept. But what I'll say is, we have to go beyond recycling. And I think recycling, there's a lot of challenges with the supply chain of how you recycle finished goods and how you reincorporate those materials from a product circularity perspective. But what I'll tell you is everybody should be using pre-consumer recycled waste and incorporate that back into your system, because one, it's more productive, and two, it reduces your waste profile, right? So we do stuff like that. But you can't rely on that to reduce your carbon footprint. So this is an EVA product. It's 2.86 kilograms of CO2 per insole, okay? Just a simple insole that goes into your shoe. If you incorporate 10 to 20% recycled material, you basically drop it nominally by about a couple points of carbon footprint. That's not going to make an impact if that's what you're trying to do as a part of your ESG mandates, whether it's a brand, a corporation, or retailer. That's not going to move the dial. What's going to move the dial as you start moving to plant-based? Our specific product is 0.38 kilograms of CO2 equivalent compared to an EVA product, okay? That's a significant reduction in carbon footprint, verified by life cycle analysis, verified by third party. So what we're trying to explain here is there's a lot of opportunity to move to net zero by working with plant-based materials, whether it's our material or not. You should be moving to plant-based if you're looking at alternatives or carbon reduction along your supply chain. There's a lot of discussion about biodegradation. I think it's important to kind of give data to understand what biodegradation means. If you want a compostability certificate, you need to degrade in 45 days up to 80%. So this material doesn't. But what it does do is it degrades over time. I liken it to a tree has fallen in the forest and you can watch it degrade over the years, but a tree is made and designed by nature to withstand the elements, wind, and other things like that. But it does degrade, and it does not impact the environment when it does degrade over time. We have to build products to last. We need enduring performance. You need something that will last over a lifetime of its use. And in fact, if you're doing much better on your carbon footprint, if you're prolonging that user cycle. What we've been able to show here through our patented technology is the orange line is our existing technology today. That's the technology in the market. We've patented a technology in the US, Canada, and Europe that basically increases that capacity of linear degradation over time while we are not decreasing performance or have not affected the life cycle or the impact of the product at all. So it's the same product. You wore it on your feet, you wouldn't be able to tell the difference, but this will biodegrade and linear over time. And we think that this material, because this lab data cannot correlate directly to nature, but it should degrade in 5 to 20 years, more likely 2 to 3 years in nature, okay? So if we're trying to make impact, this goes back to the life cycle analysis and carbon footprint. If we're trying to make impact, there's a lot of discussion today around the use of recycled materials. And this is another case study where we're talking about a lot of discussion around the upper of a shoe and how you can utilize recycled material to significantly reduce the life cycle or the carbon impact of that product. If you just use a recycled upper, you only can possibly reduce that by 9%. That's probably a pretty high number, but we're giving people the benefit of the doubt on this one. So 9% can reduce by just using an upper of a shoe. But if you actually look at an insole and midsole, you can actually reduce that by 30%. And that's not including the opportunity to reduce it further with outsole or even using a plant-based upper, okay? So again, trying to own in on this point that if you're really trying to reduce your carbon footprint, you have to go beyond recycling. We're not telling you to stop recycling, we're telling you to go beyond it and start working with plant-based materials, again, ours or anyone else's. These are our partners. We have a lot of opportunity, but we are commercial. So I will say that you can buy these products today. Today we work on insole and midsole material as a foam product, but we also have thermoplastic technology and a variety of other coatings and other products, which include a plant-based leather alternative, which I'll explain a bit more in a second. But really, what we're trying to do from a competitive standpoint is offer you not only a industry-leading 70 to 80% plant-based eco-foam, but more looking at carbon reduction and quantifying that with third-party data, and offering you opportunity to discuss other elements around the performance metrics. So low compression set, meaning enduring performance. It means it will return to its shape and comfort time and time again as you wear it, and other elements of the technology itself, which is patented. So any technology we have in the marketplace may have 2, 3, 4 patents included in it. So this is really where we're trying to transcend and move the discussion forward. So we can obviously do insoles and midsoles, but we're trying to move into a direction of being more ubiquitous across multiple verticals or industries. That is the upper or the outsole of the shoe, combining more opportunity to reduce your carbon footprint, taking that 15 kilos down to 3 or 4. But the opportunity that we've devised is a technology platform that can transcend foams and move into a variety of other materials like a plant-based leather alternative, which is going to be commercial in the next 12 to 18 months. That allows us to move not only to footwear products and consumer goods, but now moving into industrial goods that include offices, homes, and even the automotive industry. So when we talk about impact, we try to quantify this in every possible way, and today the impact is really the equivalent of taking a lot of carbon out of the environment by what we've manufactured commercially, okay? Which is the equivalent of 97,000 trees planted and the amount of carbon we've taken away by replacing petrochemical-based products with plant-based products. Thank you very much, and step into a sustainable future with Evoco and anyone else doing plant-based materials. Thank you very much.